So here's our tree diagram. 40% are female, 60% are male. 85% of the females attended romantic comedy. 50% of the males attended the romantic comedy. No moviegoer attended both movies. So now F is going to be the event that a randomly chosen moviegoer at the small theater that evening was female. Now notice this. Here's the event. The parentheses, that a randomly chosen moviegoer at the small theater that evening. That's all a prepositional phrase. That all really doesn't have a whole lot to do with the actual working of the problem. This part is just to keep your problem honest, okay, to make sure that you're talking about the correct thing. And in statistics, you'll find that a lot of times the wording is really important, and it'll seem odd because you have to be very specific. So that all of that is just to say, let F denote the event that a person was female, and then see this symbol F bar, okay? This is going to be the opposite. This is the complement of F, which in the end is male. So F bar is male. R is going to be romantic, and R bar is going to be the war film. Okay. Also, so we can say F and not F, R and not R. Female, male, romantic, war film. So here I've listed out all of those numbers that we got out of all that reading. And then the question is, fill in the blanks. So see how there's these blue blanks? We want to fill all those in. So the first question is, what's the probability of female? Well, female was 40%. So, and also they give you a hint down here, not female is 60%, 0.6. So female plus not female has to add up to 1. And so female is 0.4. So what's the probability of romantic given that the person was female? Well, that was the 85%. So if 85% of the people did this, what was the probability of wartime given that a person was female? Well, that would be 15%, 0.15. Continuing on down, if the probability of the romantic given that a person was male was 50%, what's the probability of war given that the person was male? So see how these are the two possibilities for all the men to have gone to. So we are split between romantic and war, so 50% and 50%, because these two have to add up to 1. Now we ask the question, what is the probability of F intersect R? F and R. Well, F times R given F. This was the rule for probability, for the multiplication rule. So 0.4 times 0.85, 0.4 times 0.85, well, that comes out to 0.34. For the next one, the probability of war given female times the probability of female times the probability of war given female. 0.4 times 0.15 is 0.06. Then the next one, 0.6 times 0.5 would be 0.3. And then the last one, because the probabilities here are the same, that'll be the same. So to check, we need to make sure that all our probabilities add up to 1. So 0.34 plus 0.06 is 0.4 plus 0.3 plus 0.3, that is 1. 0.4 plus 0.6 is 1. So what is the probability that a randomly chosen moviegoer attended the war film? Well, where are the people that went to the war film? Here is war, the R bar is war, and R bar is war. So 0.06 plus 0.3 is 0.36. It's the number of people that attended the war film. Does the tree diagram make sense? Okay. It's a pretty convenient way to get some probabilities that could be hard to keep track of if you didn't have a way to lay it out. Okay. Just remember that there's lots of hints just right in here. The two parts of one section should add up to 100% or 1. So the top and bottom bar right here should come out to 1. The top and bottom of each of these individual ones comes out to 1, so the 0.15, 0.85. And then going out along the bar, it's almost always multiplication. Okay, so there's a couple little hints for you.